Today, Adam's going to go over linking and deriving parts in Inventor specifically. I know that this is a topic that gets frequently asked of our support team, of which Adam is a crucial part of. So figure, let's just go ahead and do it in an AVA. And, maybe you don't have to call us and you just, you learn from this AVA. So save everybody a little bit of time there, maybe learn something new. Adam, do you have anything to add before we jump straight into this?
Yeah, I'm feeling good. Yeah, I'm hoping this should be a good one. Yeah, this one in particular comes from the heart, so I hope you guys enjoy this presentation.
Absolutely. If you have any questions anytime, go ahead and drop them into the questions panel. Whether it's related to linking and deriving parts or something else entirely, we'll try our best to answer them. I know Adam is also an expert at many other things. So if you have any matcha brewing ideas, Adam's your guy. So with that, Adam, go ahead and take it away.
All right, let's get into it, boys and girls. My name's Adam Evangelista. Thanks for the warm welcome, Nigel. As always, happy to be here. Today is December 10th, 2020. We are coming up on Christmas time, so thought I'd give you guys a little treat present in the form of this AVA about linking parts and deriving parts in particular. Let's get into it, see what we got going on here today. It's a bit about myself. I'm not sure if I still need to do these introductions after being here for so long, but I am an application engineer here at Ketiv Technologies. Essentially means I work with a lot of the different software solutions that we provide as a company, right? We're talking about lifeline support, of course, if you guys ever called in, if you needed anything for Inventor or AutoCAD, your install needs and the like. I do a lot of Inventor, I do a lot of Vault nowadays, some stuff in AutoCAD as well, but it feels like less than usual this year, I don't know. But as Nigel said, if you had any questions about, how this kind of stuff connects to anything, it's kind of a good place to start because we have all that information. Great, everything works well together. Before this, I used to work at a makerspace over in Los Alamitos in Southern California, where we worked with a bunch of fancy fabrication machines like laser cutters and CNCs and 3D printers and the like. And I just got a 3D printer recently myself, which has partly informed this presentation over here. But happy to be here. Thanks for having me. Let me know if you have any questions. I wanted to start this presentation with a few questions specifically, right? I know we typically focus on a particular functionality and kind of derive a presentation off of that, but I really want to kind of frame this particular presentation with a problem that we want to solve, in particular, a few questions, right? You might be working on a particular project, maybe you're making molds, maybe you're making two interfacing parts or something like that. And at some point you're in the software and you're like, how the heck am I going to transfer information from one part to another, right? This is something as simple as just interfacing a hole for a screw, for example, making sure that the screw is the right size for the hole, or making sure that the spacing is the same, making sure the molds are going to be the right clearance or something like that. Parts don't exist in a vacuum, and they often have established relationships to other parts that need to be identified and qualified as well. Okay. And so that's the big question, right, is why? And to kind of expand on that, the real question is like, why do you want to transfer information from one part to another, right? And the overall answer to that is going to be largely based around efficiency for the most part, right? We're talking about reducing human error. We're talking about getting the computer to do all of this kind of calculation and tedious relationship tracking ourselves. In some of my personal projects, right, I end up having just like a little notepad where I write down dimensions or something like that. And I have to look back and forth with the screenshots to make sure that I'm putting in the right dimensions. It would be great if we could get this all kind of associative, which is another common term in Inventor you guys might be familiar with already, using like assemblies and creating parts in the assembly environment. And that's part of the workflows that I want to discuss here today, is how to utilize that associativity to your advantage, because we're going to try to reduce error and increase efficiency. Okay. And getting more technical, another level down, right? The next question we want to ask is, what information are we going to try to transfer from one part to another that will help us increase our efficiency? And the two main things to keep in mind are going to be dimensions/parameters, right? And so this is going to be like largely numeric linear dimensions or something like that, right? Just this is X wide and Y tall or something. And we want to store that as some kind of parameter going from here to there. And similarly, geometric references as well. It is a small nuance between those two, but there's a difference between just having pure geometric references versus just pure numeric references. in your part. And so we're going to explore kind of both sides of that coin in particular. Does that make sense? Yeah, is that something you encounter a lot yourself, Nigel, kind of working with larger assemblies and trying to develop parts, you know? Oh, no worries. All right. And so that's the main question, and that's kind of what I wanted to frame everything with, essentially. And to help kind of direct that conversation, I'm going to go ahead and present another slide here. And the main reason this whole conversation came up and the idea for this presentation came up is because I had a customer recently. We did a training for them, and they were looking for a very specific workflow for the product that they were developing, right? This particular company, I won't name them here, but they designed concrete molds specifically, right? And they didn't do the castings specifically, right? They designed the molds for the castings. And so as a company, like people would come to them, they would ask them to, hey, like, can you make a mold for this type of, you know, concrete casting or something like that? And they would provide the dimensions via drawing or some kind of intermediary file type or something like that. This could be something simple as like concrete tubes or some like concrete art installations and stuff like that. The main idea was that, again, these guys are the ones that make the molds for these interesting casts for concrete, right? And the company itself was interesting. They had a good mix of stuff, right? And even though they did some more like artistic moldings and stuff like that, they did do a lot of standardized models that had very specific parameters varying from project to project, right? So in the case of these concrete tubes and shells, right, you're talking about some standard thicknesses, standard lengths, standards, you know, inner and outer diameter and schedules and stuff like that. It was an interesting one. And so, you know, obviously if there's some kind of space to be standardized, you want to be able to automate that as well as possible. And with an inventor, there's a lot of pathways for that, of course. And we're going to be discussing some of the solutions that we presented to them as a company, right? You know, they also had some interesting stuff where certain features and components were dependent on initial parameters as well. So, you know, if the pipe was, you know, X amount of feet long, they would have, you know, 10 or 11 or whatever number of latches to seal it all together. So it was a really interesting one. And again, they had a very standard workflow that they wanted to be able to automate and be able to work a bit quicker, getting these casting models from their customers so that they could develop these molds a bit more effectively, right? And so, you know, how are they currently doing this kind of relationship between the casting and the molds? Well, as you can imagine, it was very meticulous tracking of the parameters at pretty much all levels, right? They would get these files and then they would like start tracking. They would try to develop the model, the casting inside of Inventor, assign some parameters, and then they would start tracking those parameters and copying them into the next drawing and try to do that. You guys might be aware of some ways to do it already, which we'll get into, but the main thing was that these changes were any kind of changes to the moldings or any kind of adjustments had to take this kind of overall change across the whole workflow where they would have to change multiple models at the same time. And it was very kind of time consuming, very meticulous and very complicated. And they're like, are we doing this right? And honestly, they weren't doing it wrong by any means, but there are some ways that we could improve that particular workflow. And so in the case of being able to transfer information from one part to another, in the case of like a casting to a mold, right, there's a few different options for us, right? We could, of course, do the linking parameters stuff, which I'm going to start with myself. Linking parameters allows you to specifically just take parameters from one part and put it into another part to be used like your regular parameters. I'm assuming you guys are all familiar with parameters as well at this point, but let me know if you guys need a refresher on that as well. And the meat of this conversation I want to talk about is the derive part command as well, which not only allows you to transfer parameters into another model, but it also allows you to link the solid geometry into the model as well. Okay. And that overall just, it's good because it has everything that linking parameters could do for you, plus all of these extra controls as well. And it enables a lot more kind of advanced workflows and stuff like that. And then when I was writing up this presentation too, I was thinking that, you know, you could probably do a lot of the stuff with like iLogic too, but that's probably a more tangential conversation, but a good seed to be aware of regardless, okay? Does that make sense so far for everyone? At this point, I want to do a quick example for linking parameters, and then I have another example for derive parts command to kind of demonstrate how this kind of mold making process could go using the derive part command. Yeah, so I'll pause there just in case I've lost anyone or if anyone's, you know, anyone's super excited and they want to tell me how excited they are. All right, looks like we're good on that front, so no worries there, everybody. And so, oh, we got a question here. What kind of 3D print? Oh, thanks for the question, dude. I have a Mars Elegoo 3D resin printer right now. It's been fantastic, and I will pull up some links for you guys later. Yeah, so the resin printers are really cool because I've been holding off on it. I mean, I think FDM is pretty cool, but the resin one, the resolution is just kind of outstanding. Regardless, let's start with this linking parameters, real basic stuff, right? I have an extra project file right here. Nothing fancy in this project file. It's just a new project file. And so just to get the conversation started, right, the most basic kind of workflow you could do when you're trying to link one part to another is going to be just straight up linking parameters from one part to another part, right? This is going to be a really simple example here, but let's say we want to kind of have two interfacing parts, one with holes and one with rods so that they could connect together using the same spacing information that we're interested in, right? But really basic, we do something like this. We give this like a 12-inch width over here, give this like a 6-inch width over here. And then we'll go ahead and define these parameters. It's going to be pretty blunt with this. Width is 12, length is going to be 6. And we'll go ahead and line this up as well, make it pretty, like so. Beautiful, okay. And then we're going to place some kind of work points here that will allow us to kind of just center these along the center over here. I'm going to do a little cross beam over here, make it a construction line, add some points. 1, 2, 3, 4. Okay. And we're just going to make this a spacing. Let's see. So that's going to be 3 inches to make it even, I believe. So we'll call this spacing is equal to 3 inches. You might hear that car outside. Those are my neighbors. They're very lovely people, I'm sure. Yeah, working from home is cool because you have all the sounds of the neighborhood come in during my presentations. And I'm just going to use this the spacing parameter kind of just inform this, right? This is all very like direct and not terribly interesting, I'll admit, but essentially, oh, actually, you know what? I want to make this, yeah, it's fine. We'll make it 3. I'll just do 3 inches for now. So we'll do 3 right here. And so I do want this to be the spacing parameter. All right, I don't have to make this particularly interesting here, but the spacing here between all these points is going to be 3 inches. And if I check my parameters over here, you have these named parameters with length spacing, 12, 6, and 3. And those are all going to be, usable parameters once we start linking this in there. You can technically use like the export button over here. I was never really sure how important that was because when you do the link anyways to a model without these export parameters, it'll set it to export anyways, which I guess we could do really quick just in case you get that error message. So I'm going to finish this sketch, for example, and we'll extrude it like 0.25 inches, sure. And we'll do like the whole command over here after we share the sketch, just so that we have a proper reference or something like that, right? So I'll go ahead and click OK. And again, if I wanted to, I could come back over here and we could make spacing something a bit more interesting, maybe like 4. And we would expect the spacing to update after we hit the update button, make it 4 inches instead, right? Could I have chosen a better orientation for these holes? Absolutely, but I think the concept stands here. Export parameter exports to an I property. For reference, I believe that you need the export property. Beautiful, thanks guys. Appreciate the info. Yeah, so just for heads up, right? The export parameters one, this is especially useful for using iLogic in particular. So once you click the export button over here, it pushes it to be used and visible in the iProperties iLogic environment specifically. So just a heads up. I'm going to save this part right here, and I'll just call this linking parameters A. And if we wanted to, we could go ahead and make a new part right here, standard. And the first thing I'm going to do right here, I'll throw a save really quickly. Linking parameters E. And we're going to go ahead and just link in the other document that we have over here, right? So this is the part that we just made, right? Linking parameters A. You get this dialog box, and this is going to show you the link parameters dialog. You might already be familiar with this. This kind of interface shows up a lot during certain commands inside of Inventor. But essentially, you have like these tennis balls that are going to be toggles to either include or exclude these particular numbers and parameters from this file. In this case, right, I mean, I do only want the name variables here, but you could easily click the whole folder to, and this is the error message I talked about earlier, but you could easily click that on. It'll automatically bring everything in there for you. And you'll notice this kind of half icon as well if there's like a mix of enabled and disabled icons over here. Nothing to be worried about, but in this case, I just want the name parameters like so, right? And at this point, these two parts are linked together. And I'm kind of rushing through this just because it's a pretty simple thing, right? It has a direct file path to another part, and you could essentially choose which parameters are going to be usable in here, right? And so now I could even like use these parameters inside of my own new numeric ones over here. So, you know, I could call it like A, and A is equal to, you know, width minus 1 or something. And so we expect that nominal value to be 11, right? And so now we're kind of using the original part to inform the secondary parts with all this extra information. And that's how linking parameters works at the most basic level. And, you know, from here, I'd probably just draw a simple square, and, you know, you could go ahead, come in here, call this out, and you could start calling in list parameters. We're going to do width right here. All right, same thing over here. And I'm pretty much just using this like I was in the previous part, except I'm in a brand new part using the same exact information. So this just keeps everyone kind of accountable. It keeps everything kind of in line. And again, for the example from the customer, right, they were specifically doing this so that's they could base everything off of a singular mold, right? A singular casting, which I thought was interesting because, yeah, ultimately what ended up happening with them is that they had a singular mold that they would end up putting and linking into all of their resultant parts to give them information and use those parameters for everything else, right? I think they even ended up developing a template for what they needed so that the template would always have those parameters in them, right? So that might be an option too. I think that's a really interesting kind of system because now the template is baked in with even more information than just, you know, some application options or drawing options or something like that, right? And then from here, you know, you could go ahead and I'll probably just extrude this at this point, right? Extrude this and make it 0.25. Then maybe start a new sketch, draw a few circles over here. And then maybe we could go through and I'll make this horizontal for y'all, don't worry. Okay, and then now we could go ahead and pull in like the spacing information, right? Yeah, and so like conceptually, I think this makes a lot of sense. And the only kind of catch to this, that does require a bit of like foresight when you're designing these kind of original parts for yourself, right? Because you need to know what can and can't be used down the line for everything else. So it does take a bit of setup in that regard, but I think you'll find that it pays for itself pretty quickly instead of, again, keeping a sticky note on your screen or something like that, that'll let you know what the spacing needs to be for this particular stuff, right? And so now I could go ahead and extrude these lengths over here. Call that 1 inch. I'm going to click OK. Come back to the original part, change the spacing to something more, you know, palatable, like 3 inches. Done. Throw an update over here. And we could throw an update here as well. And that should update the spacing accordingly with these two, right? At this point now, I could go into an assembly and I have a lot of confidence that these two parts are going to be able to interface pretty well so far, right? Again, this is like a pretty basic level, how do you link parameters here specifically, and this is kind of the first step for that customer in terms of setting up these relationships between the casting and the molds that they were making. Do you guys follow me so far in terms of, yeah, I guess the linking parameters so far? This is kind of like, you know, this is probably the first thing you'll come across if you look at the traditional learning material for Inventor. Linking parameters, you just link the parameter just like that, pretty simple, okay? So nothing too crazy over there, but I would like Yeah, unless there's any other questions, let me know. So nothing too crazy there, I don't think. But at this point, I do want to get a bit crazier, and I do want to talk about this particular command up here, this derive component command. There are like derive and simplify workflows at the assembly level that some people might be familiar with, where you end up like, deriving a new part or like shrink wrapping a new part or something like that. And I think some of the language does kind of overlap there, but some of the purposes also overlap here too, which is kind of interesting. But let's talk about what this derive component does specifically. If I click derive components, it'll ask me to choose another component to essentially bring into my current assembly. And so let's switch to a more concrete example. For example, I've been talking about molds and everything like that. I've also been into mechanical keyboards this year as well. And so that's part of the reason I got that resin printer specifically, is that I wanted to print and mold my own keycaps. And so when I talked to this company about their concrete molds, I was like, dude, I could totally use this. And so to start, I do have a custom content center set up for myself already. What I'm going to do, I'm going to pull in a reference that we're going to use. Right, so I'm going to use this C row 1 unit width piece right here. This is a regular keycap. Right, nothing too crazy over here. And you'll notice that this is a standard unit right here, but what am I saying? Yeah, this goes in the C row of your keyboard. It has a few unit modifications, so there's different widths available. I'm going to start with the single unit width, but that'll be relevant for later. I'm also going to place this as custom, so I could break it off from my custom content center, and then we could edit it as we need to here, but that's not necessary by any means. Okay, I'm going to place this as custom right now, and I'm going to call this keycap casting right here. Cherry MX. Oh, Claudio's a casual dude. I can't believe he's into Cherry MX keycaps. I have some glorious Panda ones right now. But just call that glorious casting right there. These are actually based on a Rama keycap from a keycap seller that I like a lot right now. But I'll show you some links later if you guys are really interested. But this piece right here, this is a piece that I'm looking for. And again, this is based on a custom content center. So I already have some name parameters and stuff like that here. So I'm going to right click and open this particular piece right here. And since this is as custom, I could go in and I could start editing all the stuff if I wanted to. The big thing here, right, this has like a base width and it has a face length and stuff like that. All these properties come together to define this particular casting, which I molded from scratch, I sculpted from scratch. And the big modifier you might be interested in is this width modifier, right? Which we could change down the line to make it thicker or bigger. So 1.25 should update this accordingly to make it a bit thicker, right? And so I'm going to save this really quickly. And now you might be wondering, it's like, Adam, okay, you made this. You could, one, just send this to the 3D printer by exporting an STL if you really wanted to. But two, we could also develop molds out of this particular solid model as well at this point. Can you also develop molds off of the actual printed cast itself? Yeah, but that wouldn't make for a good presentation. So let's make a new part right here. So I'm going to make a new part, and we're going to save this as keycap mold. I'll say keycap mold bottom. We'll just call it A. Keycap mold A for now, and this is going to constitute the bottom of this, right? So now we're in a position where it's like, okay, great. You did all this great work with this particular IPT. It does like all these great curves and stuff like that. How the heck are you going to get that information in here? Your first instinct is, of course, you could link it, right? Just get a reference to that direct cap and you could get the parameters and just reconstruct it and do what you need to do, right? That's fine, but you'll find that with the apparent complexity that's present there, you're going to end up with a lot of, it's going to be a lot of extra work. You can easily recreate the kind of negative volume over there if you want. Absolutely, absolutely. So I'm gonna, well, yeah, Claudio, can you use a similar process to develop a mold as a means to derive the internal volume? Yeah, that's actually really interesting. Yeah, absolutely. And yeah, again, I've actually come across some tangential workflows for that specifically, but let's see what this looks like. So the first step to making the bottom of the mold right, I need to click Derive first of all, and it's going to ask me to select a reference to open, right? In this case, I'm going to go ahead and open my keycap casting right here, right? This one that I've made. And it's going to give me this similar dialog box, right? you'll notice this looks pretty familiar, right? The only difference to the link parameters dialog that we have so far is that this particular workflow also includes the solid bodies and some of the other work features over here. So we have the parameters folder at the bottom over here, which yes, I want all of these parameters. And is there a name parameter here? User, no, I'll just have to select them, it's fine. And so, I want all the parameters. Just give me all the parameters, let's say. And we also have the selection for the solid bodies. This is actually two solids here. There's one that's invisible, but I only want the bottom one here in this case. And you also have the option to choose, do you want this body to come in as a work surface or do you want it to come in as a solid reference, right? For our purposes, I'm going to be choosing a work surface specifically to give it a bit more, give us access to some of these surfacing commands, which will allow us to develop some more interesting shapes, okay? And another topic that came out, tangential, but you could also do a scale factor over here as well. I think that might be the only way I could get in like an actual tolerance gap or something to account for shrinking, but regardless, I'm going to input this. I enable the parameters over here. I enable the solid that I wanted, and this is also going to come in as a work surface right here, right? And why is this coming in with the first molding already? That's the wrong size that I wanted there. Oh, it's because I have the unit mod here still. So I'm going to call this down to 1 really quick. All right, I'm going to ask this to, is that updated, please? Unit mod, thank you. Ask this to update as well. There we go. And so notice already, right, that same linking parameter where you have the kind of true definition right here, that's also still going to be associative to your derived part component, even though it's just a command feature line over here. And at this point, we could start doing some interesting stuff, right? Claudio had mentioned getting the internal volume. Thankfully, for getting internal volume, that's really easy to do when you start working with surfaces in particular. So I'm really interested in this internal volume to make up the bottom of my mold in particular. So why don't we go through over here? I'm going to run a patch off of this bottom loop right now. It's going to automatically fill in a patch. And using those two surfaces, I could define an internal volume, right? So I could use the sculpt command here, where if you choose one surface and second surface over here, you could then define an internal volume, right? The sculpt command is a bit finicky, but you can see I've chosen the two surfaces, and I'm going to choose like the orientation of these surfaces, or how it's going to start defining its stuff, right? It's a bit finicky, but I'm pointing it both inwards because those are both kind of the internal directions, quote unquote. You might have to play with that a little bit, but you're going to see that this will develop a solid inside for you as you would want it to, right? And at this point, you might be able to just, go check on your eye properties, and you could check out your mass and stuff like that for the volume and everything, right? So that could be an easy way to get internal volume calculations, especially if you're doing like CFD and stuff like that. That's really common to use the patch and sculpt workflows right there, right? And at this point, maybe I want to do another extrusion because I'm making a mold, and I would just probably make an extra square right here, and I would just offset this very slightly from the edges, call it like 0.1. Right, call this 0.1 as well. I'll project all these edges first. I'm sorry. Oops, not what I wanted. Project these edges over here. Am I talking fast today? I feel like I'm talking fast today. Dimensions, please. Why can't I get this dimension, please? Am I crazy? Not sure why I can't get that dimension. Am I crazy? I'm going to redo this. Hang on. So I have this, I have a mold, and my surface body is still visible if you do want to see it turned on again. But all I'm really doing, I'm just going to come down here, and I just want to start a sketch on the bottom. And I should be able to project this, no? Project the surface, and I should be able to make a square off of this as well, no? Dimension this guy. Maybe I'm projecting the wrong surface or something. And this is going to be D. Why can't I project that? Am I crazy? Okay, well, I'm going to project off the surface instead. That's fine by me. 1. And the only main kind of takeaway here is that I'm setting up these references in relation to the existing model, right? So any kind of any kind of upstream changes that I make, like we saw originally, like the width, that should update with this particular bottom here as well. So I'm just going to grab this, and we do want that inside too. And I'm just making like a small little base for ourselves, right? Something like that. And if you're in the mold making process, you'd also probably go through and just actually just make this as, get some registration marks or something, but regardless. And at this point, right, we have kind of the bottom of our cast over here. And again, it's still fully driven off of our first definition, which is, again, the main takeaway. So I'm going to throw a few saves over here really quickly. Go ahead and click OK. Go ahead and click OK. Save over here. I'm just going to bump this up to like a different thickness. So like the 1.5 for, I don't know, my enter key or something like that, right? It should update that. Go ahead and click done. And if we did our job right, this should update as well accordingly. So now this particular molding, this negative molding for the bottom, is going to update with the particular model definition that we have. And that's a really powerful tool in itself, right? Because you normally only see this type of associativity when you're in the assembly environment trying to do your thing, where you like make a part referencing the rest of the assembly. What I'm offering here right now is that you could do that same type of associativity without the extra kind of information on your model browser and within the specific part environment, which I would argue is maybe a bit more intuitive for kind of more complex designs that would get even more complex than this. But I'm sorry, it'd probably be more simple to approach sort of stuff like that, right? And I think we're doing okay on time. So I'm gonna do the other half of this particular mold here as well, which you could start doing it with this again, because you could actually do another derive off of the same part if you wanted to. It just counts as another feature line. But I'm going to break it off into another part just for simplicity's sake here. And I'm going to save as keycap mold B. And I'm going to do another derive, right? And this time in particular, I'm just going to go ahead and do the casting one more time. Should be, again, the same size. You could choose the solid bodies if you want to. You have a choice between how to make the solid body now. I think I'm going to go ahead and just make it a single body at this point. And then I'm just going to fill up the bottom with our information over there. So now I have the keycap once again. It is a derived casting, which is good. And from here, I want to make the kind of the other end, right, where it's going to surround the top of it instead. So very similar game. I'm going to go ahead and do a patch along the bottom, right? Something like that. And then you could go ahead and do the sculpt. And now it's a solid body. Since this is only the top half of the mold, I don't care about the inside. But again, I'm still using that casting to drive my definitions over here. And from here, I would go ahead and I'd probably do something like this. And I would go ahead and project geometry, something like this. And I'll draw another square, something like this. And this should be the same definition over here, so 0.1. And again, there's a lot of other opportunities for additional kind of associativity. And the spacing that I'm choosing right here is specific because I know it's going to work because that's what I was doing in the last one, but maybe something you'd want to standardize as well while you were doing this. And so I'm going to do that and make a mold. Other direction, please. Okay. And it's going to go that way. I do want this to be a negative. I want this to be a new body at this point. So I click new body, click OK. Now I'm going to use the combine command, which will allow me to use some Boolean operators on my guys over here. And I could essentially use that keycap mold to cut out the bottom over here. Okay. Does that make sense? You guys with me so far? And again, right, essentially looking at it like this, where if we again drive this initial definition over here, so now I want this to be like a 2-length one. Pretty sure 2-length should still work for us here. Click done. It's going to update my subsequent parts accordingly. So now I have a mold, shows up like this. And I also have the top half over here that it would update like this, right? And so at this point, at this point now we're talking more about mold making than we are about anything else, but you'd probably want some registration marks over here. You would probably put this into an assembly or something like that, but these are both solid bodies that you could then either just send to a 3D printer, for example, to start developing your molds. I don't think you'd want to You could possibly, I'm not sure if that's a legitimate workflow. You probably want to do like silicone or something else that releases a bit easier. But yeah, you could use these as mold castings or something like that pretty easily. And the main takeaway again is that you could use any type of model like this right here that eventually informs how you develop the rest of these related solids for the actual molds and castings, right? So I think this is especially relevant for mold making in particular, where you need these exact references, not even necessarily the parameters like you would maybe expect just going through a regular link parameter workflow. But in this case, the geometric references is really what helps us drive this, which are all enabled thanks to the derive command over here. Again, that's to say nothing of these surfacing command workflows that we used along with the Boolean combined commands over here as well. Are you guys with me so far? Again, I hope I'm not talking too fast. I hope that was at least informative. It'd be nice if we could set like I wish I had like a glass setting or something like that. I forget which one of these are transparent, blue. Yeah, something like that, right? And maybe we'll do that over here. Yeah, we'll do like clear blue over here too. And we'll make an assembly really quick just to finish this off. But are you guys with me so far? You guys like following me? I'm going to save this, go and click OK. I'm going to save this, go and click OK. Make a new assembly really quick. Yes, let me know if you guys have any questions or anything. Yeah, I hope I'm not losing anybody here. Place grounded at origin right over there. And we're going to also place in the top half over here, which would be part B. And now we have our molds. Look at that. Look how nice that looks. Gee whiz. Okay. Right. And then, you would probably just come in over here, start constraining this stuff so it matches up. Or if you had registration marks, you wouldn't need to do this, but, c'est la vie. Right, and then you would just clamp it down and you would expect the resultant volume to be exactly what we need over there. Pretty neat, right? What do we got here? We got some questions. Mario Silvaro, doing great, easy to follow. Thanks, man. Appreciate that. Chat, what do we got here? Yes, fine speed. Love it. Cherry MX. Okay. And so yeah, I don't know. I think that's all I really have to say about this. Are you still there, Nigel? Do you have anything to kind of add to this really quick? Otherwise, I might just tie this up really quick.
Yeah, you're doing good on time, Adam. We can wrap up in the next couple of minutes here.
Cool, man. Yeah, and so yeah, I think this workflow is super interesting. Like again, it only kind of came to my attention when I was working with that customer that was making molds specifically. This is from Jesse over here. It seems like our experienced derived parts carry significant computational overhead. What cautions can you give us for using them in large assemblies? I'm not sure I could say, honestly. Let's see. Experienced derived parts.
When you're looking at it in the sense that it is adding computational overhead, that's correct, right? Because essentially it's referencing two items instead of
kind
one.
Of nested in itself.
Exactly. So what I do suggest is not doing derives within derives within derives. It's the same thing of like, don't do I parts within I parts within I parts.
That's, kind of like XRefs and AutoCAD as well.
Exactly. Yeah. So don't go super deep. Don't like try to play Inception with your derived parts.
Absolutely.
Yeah, I would.
It might be interesting too.
You're just opening so many more instances.
Yeah, absolutely. Because you could also do like, once you have these parts, right, you could also just start deriving these and like shrink wrapping them or simplifying them as well at that point. And that should break the link back to the original part, I believe, right? At least some of the shrink wrap commands, I believe.
Yeah, you can break it.
Yeah, that might be an extra step in itself, which would, I feel like, also cause issues and a bit of other type of overhead for sure. But that's an interesting point for sure. Yeah, I use Derive a lot with parts that are made from existing parts. Absolutely, yeah. And so, yeah, like I mentioned, this came up originally because I was working with a mold making company that was, having particular concerns about how they set up their stuff. And I was like, okay, well, we could do X, Y, and Z. We could do this for sure. And I think it gives kind of a nice light to why these tools exist in the first place, right? Like the Derive command in particular, I feel like is a bit, nondescript at this point. But again, being able to link information from one part to another part is an extreme utility in itself. Linking parameters is great, but I think it's kind of only scratching the surface. When Derive does pretty much everything Link does, It is everything that link parameters does. Plus you get all this extra solid geometry, which allows us to inform some more interesting design processes like mold making, for example.
I think if you take one thing away from everything is please define your models using parameters.
Yeah.
Why Inventor is called a parametric modeler. I mean, yeah, sure, it generates D0, D1, D2 and stuff, right? When you're, working in Inventor. Please name those. It makes your life so much easier in the future, especially when you do things like what Adam's doing, where you're linking parts together, right? You don't want to link D0 to something else.
Exactly.
Just makes it so much harder.
Yeah, it's interesting you mentioned that because, again, I've been into like the keycap scene recently and like the 3D printing scene in particular. And there's a stark dichotomy between the parametric modelers and then the 3D sculptors in the community, where like, sculptors are like, oh, how do I get this to be like X dimension long? And they're like, you probably want to do a parametric modeler if you want to do that stuff, right? So yeah, I mean, this is playing to the strengths of Inventor essentially. And if you let it work for you, you can do a lot of extra stuff like this pretty easily, right? There's another question here from Nelson. Is it possible to store parameters into a single file that could then be referenced by parts? Yes, absolutely. That's similar to the conclusion that that company I was talking about came to as well, where they were essentially, they had these castings that kind of served as the main definition that drove all of their resultant parts. And then they used that and they referenced it and pretty much everything else that they needed so that they could keep working and informing their other designs. Okay. And then from Claudio as well, name them, think about how to define the entire model with as few parameters as possible. Absolutely. Yeah. If you guys are curious, just a peek behind the curtain. I do have this, I do have some, you can check out my content center over here. There's a custom content center I made as well. And you can take a closer look at the family table over here to see the parameters that I use for this. The only real ones I need to define it are essentially going to be the row and the unit mod, but everything else follows a pretty strict definition over there as well. So this also ties into standardizing for content center and stuff pretty nicely, right? Okay, any other questions? We have at least one more slide that we want to cover over here, but any other talking points or anything else you guys want to see here really quick? Not a question, making machine parts from castings with derived parts. Okay. Yeah, no problem.
Jump real quick into the presentation real quick, Adam. I want to go over that one slide.
Absolutely. I'll give you a presentation here.
Oh. You can just leave it here. You don't have to open the slide or anything. Yeah. So that works too. It's fine. So as part of the end of the year here at Ketiv, if you haven't heard already, we're doing a 0% financing for 12 months. There's a bunch of details in there. There's a bunch of details to be had as well. If you have a renewal or looking at new seats or even services coming up, let us know, or at least let your sales representative know or the marketing team, and we can point you to the right direction for that. So definitely keep that in mind if you do have like a renewal coming up here in the next little bit. So that's all I wanted to go over, Adam. We can jump back into questions.
Yeah, so absolutely. I think I do have a comment here from Thomas Gray. Not a question, making machine parts from castings with derived parts, Absolutely, yeah. So I was going to say, yeah, I mean, the other end of things, I mentioned that Rama company, which is really cool. They started doing like machined keycaps and machined keyboard parts in particular. It's Rama, R-A-M-A, if you're curious. But now they're finally pivoting into like injection molding parts, which is kind of cool. But their first initial market thrust was like premium CNC metal parts, which is kind of nice. But you can imagine like all this information for molding and stuff like that ties in pretty well with any kind of like any sort of kind of mold making or machining workflows that you could think of at this point. Yeah, any questions or anything else you guys want to talk about? Again, I've been really curious about keycaps myself, and so that's kind of helped me inform this information over here. But yeah, anything? What else you guys got, man? What's up?
I think that's just about everything. I'll give everyone another 30 seconds to ask any more questions that you do have. I'll check the YouTube feed as well and just make sure there are no questions lingering over there, Adam.
Absolutely.
Give me one moment.
I'm gonna go look at my cool molds again.
There you go.
Yeah.
I think that's everything. We have 4 questions, but I have one for you, Adam.
Absolutely.
you've been talking about keycaps all day, right? But you've ignored the more important component, which is the switch. So which switches are we using, Adam?
Oh, do you want to know, dude? I can pull it up right now. Is that allowed? Is that free advertising? I'm using the Glorious Canvas right now.
There you go. The glorious holy pandas.
Yeah, absolutely. They're
Abs-
I'm not a huge fan of this website, but these are very nice keycaps if you guys are curious. We could take a look at the specs really quick as well.
oh my gosh.
67 grams
That's
right
good,
there.
Adam.
Oh,
You're good, man.
oh my gosh, heck yeah.
You're good. I actually have those keycaps, and I do enjoy them. So
Yeah,
or not
they're solid,
keycaps, the switches. So yeah, just this total aside from this webinar.
This
But
is like absolutely. Oh, and I think I did get a quick question here too from Claudio. Yeah, we could definitely talk about that. As far as internal volume goes, yeah, it'll depend on how complex the model is, right? And depending on like over here for this model, for example, I can take this back to about here, and I can take a look at that internal volume right here. I could take a volume off of this specifically if I wanted to. But you can imagine for more complex parts, it might require some more sculpting and patching specifically. But
exactly, yeah. So it really depends. Like I think that would be the way to do it, right? Is to generate the solid of the inside by using the surfacing tools, and then using the eye properties to find the volume of it. It gets infinitely more complex if you have a bunch of items on the inside of your object. So keep that in mind. It's just the same process in which you have to use some of the sculpting commands or the patching commands as well. But yeah, if you've got like, say for example, you have a tank and you've got a bunch of like pipe inside of it and you want to calculate the internal volume, it's a little more difficult because there's a ton more surfaces that you have to dodge or things like that. So keep that information.
And then we got another question here from Paul Bannister. Let me send you the link, dude. I'm using the Mars Elegoo right now. It's like super cheap right now because they just released like a new line of these printers as well. I think I'm using this guy right here. This isn't an advertisement, but it's pretty good, man. I like this a lot. Can I spend one more moment to show them my keyboard, Nigel? Is that all right?
Sure, Adam, go for it.
Nice. That's what I like to do. And so yeah, I got this resin printer. It's a pretty good entry level one if you're into that sort of thing. And let me bring up my photos really quick. These are the keycaps that I've been making recently. I've developed this from scratch. Yeah, I'm modeling this off of something else right now, but yeah, my next step here, since you could use the 3D printer to essentially, let's look at that. You could use a 3D printer to make, the actual castings essentially. And the next goal from here would probably be to make molds, like I was saying earlier. So this particular presentation was particularly well timed. But anyways, I think that's all I got, man. I'll close it out, man.
Yeah, you're good to go, Adam. Thanks everybody for joining us today. I know that this is something for Adam that was really important to put together, strictly because he has like personal projects that he wanted to share some of the process with for you guys. And those are like my favorite webinars that Adam puts together. I really enjoyed some of the thermal ones as well. So definitely, if you're looking for more learning content, go ahead and take a look at our YouTube channel. That's youtube.com/Ketiv Technologies. We've been doing these things for like 5 years now. And you can imagine every week for 5 years, we're over 250 of these webinars. So definitely take a look there. There's a ton of content, especially if you're a new viewer and you want to go back and look at what we've done in the past, or maybe you need a refresher. Just a reminder, they're all available on our YouTube channel as well. If you have any questions on how to find anything, or you're having difficulty finding any particular session, go ahead and email any of us here, and we're more than happy to help you track that down. Again, Adam, thanks for joining us today. I know that you are a very busy man, and we'll talk later today.
Yeah, thanks for having me, guys. Take care.
Cool. Thanks, everybody. We'll talk to you soon. Take it easy and have a great rest of your week. Bye-bye.
Bye.